everyone. My name is Stephen Pu, one of the co-founders of Taraxa, and welcome to our bi-weekly AMA. And today I have with us Leo, one of our core engineers. You want to say hi to everyone, Leo?
Hey, everyone. Yep, I'm Leonard. I'm the ecosystem engineer here at Taraxa.
Okay, cool. Yeah, so today we have something pretty cool to share with you guys. We're going to, Leo is going to demonstrate how we're going to deploy a local testnet. So several things I want to say before we start is that, well, first of all, deploying a local testnet is not the same as deploying a node, right? A node is just a single participant inside the network. And typically when you're deploying a node, you're deploying it to be part of another existing network, which is what we're asking a lot of our volunteers to do right now. Deploying a test network is deploying your own independent, separate from everyone else's network. And why would you want to do that? Well, you want to do that, perhaps you're curious about our features. We do also have several types of nodes inside the network, specialized nodes, besides just the regular consensus nodes. And maybe you're just, maybe you think it's fun. So today we'll have Leo go through how you would do that. And all right, let's get it started, Leo.
Hey, sure. Let me share my screen. Okay. So first thing I wanted to show off is that we added a lot of options to our binary distribution. So now the binary can also generate config files. It can generate accounts and VRF secrets, and we're gonna use those options in order to generate the config files for all the nodes we're going to run, and also use it to start the actual nodes. So the first thing I wanted to share is that we have three types of nodes in our software. So the first type is a boot node. We use this to help other nodes discover peers. So we use it to basically bootstrap the network. We have a consensus node. And this one actually participates in validating the blocks and voting. So this is like the most important one of all. And we also have RPC nodes. These RPC nodes can be used, for example, to send transactions to the network, to get information from the network. They can also sit behind the load balancer, for example. And yeah, we're gonna now create one node of each type, and then we're gonna start them, and we'll use Web3 enabled application to send a transaction and see if it works. Okay, so the first thing I would do is generate the wallet and the VRF secret for each node. So each node needs two secrets. One is the node secret that will generate the actual wallet that the node uses, and the other one is the VRF secret that we use internally for VRF. Okay, so in the new binary, we have a command. So we can do Taraxa D command account, and it will generate random accounts. You can just copy these from the text file because we're going to use them later. And then we also have a command to generate VRF secrets. So let's do 3 of those and copy them to the same text file. Okay, now that we have our wallets set up, let's start by generating the config file. The config files for each node. We're going to generate one config file and then modify it a bit, and then start each node with that template. So in the binary, we also have like a config command that takes all the options that the node does. So for example, wallet is a JSON file where these secrets will be stored. So let's actually create some directories to hold these files. So let's do a config directory, and let's do a data directory for the actual node state. Okay, and to generate the config file, we would run Taraxa config and then specify a path for the wallet. We can do config. Let's generate the config for the boot node first. So let's name it config boot. Oh, this is wallet, sorry. So wallet boot node. .json. Then the next option is the config file. So let's do config, config again, boot node. .json as well. And then let's see, what other options do we have? We have a data directory where the ledger will actually store the data. So we're going to give it this, this directory data and specify a different path for each node. So the boot node will have a path like data boot node. Let's see. Network ID. Yeah. So the network ID is used to identify the network that you're in. So for example, our mainnet will be will have a network ID of 1. Our testnet has a network ID of 2. Our devnet, which is a network where we test nightly builds and stuff like that, is free. We're just gonna create like a random network. So for example, let's do 1807 because that's the time in Romania right now. And then this is a boot node. So we have to specify this flag boot node to tell the Taraxa binary that this is actually a boot node and to modify the config for that. So this boot node's append option will use this to define our boot nodes. So in our case, it's just going to be one boot node, this one that we're generating right now. So the format is IP address. I'm going to use my local IP address. And the port number, let's use the default one for this. So 10,002. I think that's 10,002. And then the ID is the actual boot node's public key. So for the boot node, it will be this one. So let's just copy that real quick. Next. Let's also add a node secret for the boot node. We're going to copy it from here. So this command will generate 2 files. It will generate a wallet and it will generate a config file. The wallet will contain the same keys as here. So we can create that file manually, or we can use the CLI to do it. So for node secret, let's copy this. And for VRF secret, let's copy this and see if it works. Okay, so the config file does not exist. It generated the new one and the new wallet. Let's have a look. As you can see, this is what our config file looks like. This is the chain ID we set earlier, but it's in hex here. This section is pretty important. I'm going to talk about it a bit more in the consensus nodes, because we're going to use this to delegate tokens to that consensus node. This section also sets some initial balances for some addresses. And we're going to use this also. Yeah, as you can see, it stored the database path. We have some ports here that we're going to change for the other nodes. Okay, let me format this again. Okay, so the config for the boot node looks good. Actually, let's do one more thing. Let's, so I have a browser here with Metamask with just a randomly generated wallet. I want to add this address to the Genesis balances in order to give it some tokens. So in the Genesis block, there will be a transaction to this address with this amount of tokens. I don't know exactly what that means, but we're going to see that value in Metamask. The second address, as you can see, we use it here to delegate the tokens from this address to our consensus nodes. In this case, we'll only have one consensus node. So we can copy its wallet address. So this one, we can copy it here. And when the network starts, we will delegate this amount of tokens to this address. Okay. So yeah, I think it looks good. We're going to keep the default ports for the boot nodes, but we'll change them for the other nodes. So because I run all the nodes locally and we don't want a conflict. Okay. Now the second thing I want to do is copy this and create a config file for the consensus node. And the wallet for the consensus node. Wallet, for the wallet, we simply copy all of these and add them to in this file. Make sure we add commas. So you can either edit this file manually, or you can generate it with the CLI as we did earlier for the boot node. But seeing as we already generated those addresses, I'm going to edit it manually. And yeah, it looks good. And now for the config for the consensus nodes, here we want to change the ports. So this will listen on 10,000 free, and the RPC port will be 8 and 8 for the web services port. So they don't conflict with the boot node. And then we have to turn this off because this is actually not a boot node. So we'll set this to false. Okay, I think that's about it for the consensus node. So as I said earlier, we added the consensus node's wallet address in the Genesis state. And that means when the network starts, we will delegate some tokens from this address to this wallet. And as you can see here, the eligibility balance threshold is the same number. So this node will actually be eligible to vote and participate in consensus. Okay, and now let's copy this config file and this wallet and generate the files for the RPC node. So let's say RPC node, and this should be RPC node. for the RPC node, we're gonna copy all of the secrets into the file. Make sure that commas. As I said, this can be generated automatically from the binary. Okay, so this looks good. And for the config, let's also increment the ports so we don't have a conflict with the other nodes. So this is going to be 10,004. Here we're going to have 9 and 9. That's it, I think. Let's see if they start. So clear this. Let me split this in 3. I named it Demonet. So okay, so here's where we're gonna start the nodes. So to start the nodes, we already have the config file, we already have the wallet. So all we need to do is just run the binary and specify the config file for each node. So the first one is going to be the boot node. So we're going to say config, config boot node, and then the wallet. It's going to be config wallet boot node. And yeah, looks good. Okay, so the node started. This is the actual boot node. It's running right now. Let's also start the consensus node. So we're going to use the same command, but change the config files. So let's see. For the wallet, we're going to use wallet consensus node. And for the config, we're going to use config consensus node. Okay, one more thing we have to change, sorry. We have to change the database path. We could have specified that via the command line. So as you can see, we have an option right here for the data directory. We specified it the first time we ran the command, but that was for the boot node. So for the consensus node, we will have to change this to consensus node or anything else. It will create that directory and store the states there. And for the RPC node also, let's name this RPC node. Okay, let's try it again. Okay, so the consensus node started. You should see some information popping up here. We added this summary log just to make it easier for users to see what's happening with the network. So let's see if this number of peers changes. So yeah, it changed to 1 because we also started the consensus node. So that's good. Currently, no blocks are being produced because we don't have any transactions to the network. So let's also start the RPC node and create some transactions. See if it increases the number of blocks. So another interesting information here is nodes eligible vote count. So this node, the consensus node, has 1 vote. As you can see, the boot node has 0. So this is the only node that will actually vote and participate in consensus. Sorry. Let's start the RPC node. Voila, yeah. We have all 3 nodes running. As you can see, the RPC node runs on port 7779. Let's actually try to connect to this network from Metamask. So custom RPC, I have it here, Demonet. This is the RPC port from the RPC node. The chain ID, let's copy this from the config. So chain ID symbol to be Tara and save. Okay. Oh, so we have some Tara tokens. That's because earlier we added this address in the Genesis balances. So that means in the first block, in the Genesis block, we give it this amount of tokens. So now to generate new blocks, new DAG blocks in our network, let's actually send some tokens to create a transaction. I'm gonna send some tokens to the boot node, maybe. Let's copy this address. And let's say we want to give the boot node 2000 Tara tokens. So let's click next, confirm. So the reason why this is working is because we're fully compatible with Ethereum. That doesn't mean Taraxa is built on Ethereum. We just implement the same RPC calls and we can use the same tools that are used on Ethereum, like Metamask and others. So as you can see, the transaction was actually mined meaning was added to a block and confirmed. As you can see, our balance decreased by the number of tokens that we sent plus the gas fees. So that's why this number is a bit weird. We can also check this. Let's actually import the boot node's wallet into MetaMask and see if it has 2000 tokens, the 2000 tokens that we sent it. So let's copy the node secret. Let's do import account, 0x, new account. And yeah, okay. So the boot node has 2000 Tera tokens. And now we can send those back to the consensus node or any other address. For example, max, next. And right now it takes a bit for the transactions to get confirmed because we don't have our own wallet yet, and we don't implement the DAG structure that we have. That would make it a lot faster. But right now, using this tool that's made for Ethereum doesn't quite use our full capabilities of the Taraxa node. So as you can see, this transaction was confirmed. We can check it by, for example, importing this wallet too. So let's do import. Yeah, as you can see, this consensus node has the 2000 tokens that we sent. So that's about it. We can also look here and see that new blocks have been added to the chain. So as you can see, the chain advanced. As we sent transactions to it, it created new DAG blocks and new PBFT blocks. So yeah. Hope you found this interesting.
Cool. Let me ask a few questions, Leo. The first one is where can we find these binaries? Are they in the GitHub repo or?
Yeah, they are in the GitHub repo. We didn't. So this is like a beta version of the binary. We haven't released it yet, but we will soon. So version 1.6.0 will come out in the next couple of days. We can find it here. So we go to github.com, that Taraxa project, Taraxa Node, that's the name of the project. And we can go to releases. This is an earlier version of the binary, but we can find it here. So the binaries This is the binary for Mac OS, and this is the binary for Linux. We don't support Windows binaries yet, but anyone can run a node on Windows using Docker. Yeah, and in the next couple of days, we will release this new binary in this new version 1.6.
Okay, cool. I noticed that and we have RPC nodes inside the network, and I'm wondering, is it something that's going to evolve into, for example, what Infura is like on Ethereum, that we can just sort of provide like a service saying anyone can interact with the network via these RPC?
Yes, sure. Because the great thing about the RPC nodes is you can put any load balancer in front of them, and they can they can serve a lot of users. We actually do have an RPC endpoint right now that people can use. Let me share that real quick. So I think it's rpc.testnet.taraxa.io. So you can use this. You can browse. You can use it in the browser, but you can use Metamask to connect to it. For example, let's create another network. Let's say Taraxa Testnet. This is the RPC URL. The chain ID is 2, so for testnet, and then the symbol is Tara. And as you can see, we connected to that. And you can also use our Explorer. So it's explorer.testnet.taraxa.io. And we can use we can add our address to the faucet to get some tokens. So yeah, people who want to interact with our network from MetaMask can use this RPC. It's basically like Infura, but it has less servers right now.
Okay, cool. Sounds great. Yeah, so hopefully, thank you very much, Leo. So hopefully everyone has enjoyed this demonstration. I think we as mentioned inside Leo's talk, we are compatible with Ethereum. We're not built with Ethereum, but we're compatible with Ethereum. So that allows us to use all of the tool sets that the Ethereum ecosystem has, which is a very, very big advantage. Also, another big advantage is that later on, as we start demonstrating DApp development, it'll be very easy for someone to move or copy over a DApp that they have developed on top of Ethereum onto our network, right? So the other highlight, I think, is that we have several different types of nodes that are serving different purposes on the network, and the RPC node is of a special interest because it allows us to load balance queries to our network and basically, provide a nice abstracted interface to developers that how they can interact with our test network and eventually mainnet. Okay, cool. Well, let's see if we have any questions here. We had one question earlier, is that do we have any new partners? So we are very close to convincing another one of our partners to actually reveal the partnership. Like I said before, I think in other contexts, is that it's often when you have an actual real commercial collaboration with and a business relationship with a customer, they typically don't want to tell the world about what they're working on, especially if it's new and they believe that it will give them a competitive edge. So there's another partner coming up that I think we're very close to convincing to actually publish the nature of our partnership. So please be on the lookout for that. They're in the automotive logistics and supply chain arena. So cool. Let's see. We have some other questions I think that was asked earlier. So let me see. Okay. So is the Taraxa network still, is the testnet still sort of being tested? Can we start running nodes again? Yeah, so right now, actually, the testnet looks pretty stable to me. So if you want to actually try running a node, please go ahead. As usual, all of our node related discussions are in our Discord channel. So please go there if you have any questions or you want to chat with other people who are running nodes. Yeah. But as usual, right now, this is sorry, I'm reading several things. As usual, this is a test network, so it will incrementally go down. Yeah, right now it seems up. So if you want to check it out, please go. You can always tell whether or not the network is up by going to our Explorer, right? So explore.testnet.taraxa.io. You can actually see whether or not the network is up. The easiest way to tell is to see is to look at the block times, right? So typically, DAG blocks, like a second, PBFT blocks, a few seconds. So if you're seeing that, then that means the network is healthy. But if you're seeing like minutes or hours, then that means the network has hang. So right now the network is up and running. Great. Okay, so okay, we have another question here. It says our community is getting quieter, and we should promote it. Next plans to get more people involved. Yeah, so we are planning to publicize more of our more of the work that we're working on once we do actually have stabilized products. So for example, once we do have a stable testnet, once we start rolling out the staking program, and when we have the apps that are specifically tailored to the crypto ecosystem, then yeah, we will definitely promote it. So so those are all in the plans. We really believe that when you're promoting something, you should promote something that people can see and interact with. Just promoting conceptual things is a little hard to swallow, I think, for most people. So so yeah, we will be doing that very, very soon. Okay, so another question is, so when after we launch our mainnet, what type of developers do you want to attract? What type of dApps do we want to actually attract onto our platform? Is it just going to be DeFi and NFT or something else? So as we said before, Taraxa was built to track informal transactional agreements and data. So that is going to continue to be our focus, which is going to be driven by the applications that we built ourselves. So we believe that if we actually want to build a sustainable ecosystem, we need to own a class of applications and actually drive adoption on that. Therefore, we can start building network effects into our ecosystem. Now, that doesn't mean that we're gonna it's going to be an open network. We're not going to prevent people from obviously developing DeFi or NFT. And in fact, a few of our development partners have told us that as soon as we have something stable out, they would love to actually publicize the work that they've done and actually migrate onto Taraxa, and they are building DeFi and NFT applications. So obviously we would support and welcome such applications. It's just that our team's own efforts are going to still be focused on the unique applications that we're building, which are going to be driven by tracking informal agreements and informal transactional agreements and data. Okay. So another question is Taraxa's future going to be focused on the public chain or the apps? Well, for us, I think I've always said that the ecosystem that requires both, and our approach has been very holistic, right? So we built the infrastructural technology, and then we also built the applications on top in order to build a long-term sustainable ecosystem rather than just try to copy other applications. So that's an integrated approach. So the advantage is that integrated approach is that our applications will never be bottlenecked by a lack of understanding or capability to modify the underlying technology, and we can customize the technology to serve the applications. We can also build our own, application-specific layer 2s to batch process transactions so that we can indefinitely scale up the throughput of our the effective throughput of our network. So these are all advantages that we have by building the entire stack, right? So that is our focus. I don't see the underlying layer 1 technology as separate from our applications. So. Okay, what do we think are some competitive, some competitors, right? Direct competitors to Taraxa, and what are our advantages over them? From a layer 1 perspective, I think, obviously there are lots of new layer 1s coming out that has been coming out in the past few years. I think one of our core advantages is that we, without actually using sharding, we are probably one or two actually projects on the market today that's able to achieve very high throughput, low latency without sacrificing security and decentralization, right? So that's actually a very, very unique value proposition and technological advantage for our layer 1. Now, on the application side, I don't actually see a lot of people, I don't actually see anyone else building something even remotely close to what we're doing, which is tracking informal transactional agreements and data. We paid very close attention to the market. We validated these use cases, and then we're moving forward to scale them up and promote them. So I think that's a very big early mover advantage. The market, by and large, are very focused on, sort of making copies of existing successful applications in DeFi and NFT. That's something that we're not actually doing that. We don't believe that those type of approaches will be sustainable in the long term, right? The only way to build something with true network effects and sustainable and have your application not just suddenly abandon you when, for example, Ethereum gets an upgrade, is to really build up your own application ecosystem, right? Okay. So will Taraxa's mainnet come online, and how can participants or community members earn? So on the earning side, we're going to have a phased staking coming out. So initially, we're just going to have a lockup on Ethereum for our existing Terra ERC20 tokens, and that's going to help us test, just simply locking up tokens. And of course, by locking up, you'll earn annualized yield. Now, the second step is that we'll have a bridge that actually mirrors what's actually happening on the Ethereum lockup contract and mirrors those staking onto our test network, right? So that's going to simulate actual staking, right? So that we can actually run, mirror all the stakings inside our test network, and have block rewards and everything else running without actually damaging the current assets, putting any of the real current assets at risk. And once we feel that that's pretty stable, we're going to do a mainnet launch, and then we're going to have actual staking on the main network as well as on the Ethereum network. So this is going to happen in several stages, and you can all, everyone has an opportunity, if you're token holders, to actually help secure the network by staking your tokens. So our internal goal is definitely to launch the testnet, to launch the mainnet this year. So please be on the lookout for that. Okay, I think those are all the questions. We're nearing the end of our AMA. So thank you very much, everyone, for joining us today. And all right, and then thank you, Leo, for joining us today.
Yeah, thanks, Steven. Thanks, guys. Bye.
All right, bye.